finding nth roots of a complex number. And for particular that, we have to know two things more. The first one thing, when we are in the polar form or in the rectangular form of any complex number, that means any complex number can be written in two ways. The rectangular form of Z is equal to x plus iy. That means whatever we have written, that is according to the rectangular form. Another one form that is already we have, that is the polar form. And in the polar form, Z is equal to r into e to the power I theta. Okay, now that is required here also. That means using de Moivre's theorem, we can obtain roots of the complex numbers. Suppose n is a positive integer and a complex number, suppose omega, that is not w, that is omega, is the nth root of z, and that is denoted by z to the power 1 by n as usual. Then we have which one? Omega to the power n is equal to z, that is obvious, no problem. If we have that is the nth root, then omega to the power n is equal to z. Now, how we can find out? Let omega is equal to rho, that is the sign of rho, not p. That is cos of, suppose, phi, taking another type of angle, phi, plus I sine phi. And we have z is equal to, with the r, that is cos of theta plus I of sine theta. That means we can write out that theta as, check, cos of theta plus 2k pi, okay, according to the trigonometrical form, and plus I sine, same as theta plus 2k pi, where k always belongs to the set of integers. Okay, that means z. As or since we have omega is the nth root of z, then we can say omega to the power n is equal to z. So just write down here omega to the power n, omega has been taken, that one. So rho to the power n cos pi plus I sine pi whole to the power n is equal to, on the right hand side, okay, that can be written as r of cos theta plus 2k pi plus I sine theta plus 2k pi. Okay, so always where k belongs to z. Okay. So by de Moivre's theorem, what we can say, that is whole to the power n. So by de Moivre's theorem, we can say whole to the power n. So rho to the power n, and that one cos n phi plus I sin n phi is equal to, as usual, the cos of theta plus 2k pi plus I of sin theta plus 2k pi. Okay, now we can comparing the left hand side, practically the moduli and also the arguments. We have rho to the power n is equal to r. Check. Okay, and we have n pi is equal to theta plus 2k pi. Rho is equal to, hence, r to the power 1 by n. And so from here, phi is equal to, just dividing the n, that means theta plus 2k pi by n. Now, in the both cases, we can say the k belongs to z, or the set of integers. So here also k belongs to z. Okay, so what that means, what are the values of omega? Just look at the value of omega taken here. Omega is equal to rho of cos phi plus I sin phi. So here we can say the values, not a single value, practically infinite number of k. So infinite number of values. So the values of omega are, which can be written as, in place of rho, I am writing r to the power 1 by n into cos of phi. Now phi can be written as theta plus 2k pi divided by n, that one, plus I sin phi. So I sin, in place of phi, we are writing, that is theta plus 2k pi by n, where k belongs to j. Okay, so those are the values of nth root of any complex number. Let's check with one problem that would be helpful for. Suppose, given like that, let given z to the power 3 plus 8i is equal to 0. Then we have z to the power 3 is equal to minus 8i. So we can write from here, that is 8 into minus I. Okay, now that is a trick. Here is a trick, that minus I can be written as 8 into 0 minus I. Okay, now that 0 means we are writing it in form of cos. Cos of minus pi by 2 plus 2k pi is becoming 0. So that's why we are writing it as that one. And once more, we are writing for 1, that is I of same value, that is minus pi by 2 plus 2k pi. Okay, where k belongs to z. So that is resembling the our form of omega to the power n. So z can be written as cube root of 8, as z cube is that one. So we are writing it here, that is cos of minus pi, that has been taken here, 4k pi divided by 6 Okay, and plus I sine minus pi plus 4k pi by 6, where k belongs to 0, 1, 2, dot, dot, dot. Now, why 6? You can find it here. Suppose minus pi by 2 plus 2 k pi. You can write it as 2. So, minus pi plus 4k pi. Now, look at the value, that is cube root. So, here we are writing the complete using divergence, that is 1 by 3. So when 1 by 3, we are multiplying it 1 by 3. So that's why that one is becoming 6. That's the why we have done it directly by 6. Okay. So according to that, 0, 1, 2. So put out the values. So when we have k equal to 0, z is equal to, just put the value of k as 0. So that one 2. Cube root of 8 is equal to 2. So 2 of cos of minus pi by 6 plus I of sine pi by 6 minus, that must be. Okay. So here that one is becoming 2 of minus half minus I root 3 by 2. Or which one is simply 2 of, okay, root 3 by 2 minus I of 1 by 2, or that is root 3 minus I. That is when k is equal to 0. When k is equal to 1, we have z is equal to 2 of cos of pi by 2 plus I of sine pi by 2, or which one is gives us 2 is equal to 2 into 0 plus I, we can write, or 0 plus 2i, or which one is 2i. Okay, not 2, practically that one. Okay, 2 of that one. And next one we have, when k is equal to 2, that z is equal to 2 into cos of 7 pi by 6, same as, plus I of sine 7 pi 7 pi by 6. So which gives us 2 cos of pi plus pi by 6 plus I of sine pi plus pi by 6 is equal to 2 of minus cos pi by 6 and minus I of sine pi by 6, as it is from pi plus. That's why that one is becoming minus. So that is 2 of minus root 3 by 2 minus I of half, which one is becoming minus root 3 minus 1. So simply the values of z are, first one, as we have found, that is root 3 minus I. Second one we have found 2i. Third one is here minus root 3, sorry, that one must be minus root 3 minus I.